In this video, I'll be going over the 2.4 skills practice. We're covering solving equations with variables on both sides. As usual for skills practice, I'll be solving the odds for you and then leaving you on your own to try the evens. And then you'll be able to immediately check your answer. Looking at number 1, it says 5 times the sum of a number and 3 is the same as 3 times the difference of twice the number and 1. What is the number? So this goes back to the idea of like the math tricks or games we started playing last week. So we have to first decode and figure out what's happening here, and then we can solve and figure out the number. So I just want to decode what's going on here. I've got 5 times the sum of a number and 3. That kind of goes together. So 5 times the sum means I'm adding two things together, of a number, I don't know what that number is, so I'll call it n for number, and 3. The sum of a number and 3. So what that means is I'm multiplying 5 times the sum of a number and 3, meaning I'm adding n plus 3. N plus 3. But we want to be careful here because the way that I just wrote this, it looks like I'm multiplying, if we're following order of operations, I'm really multiplying 5 times n and then plus 3. But the directions here are indicating that I'm multiplying 5 times this whole thing. So how do we show that we're multiplying by a whole thing? We use parentheses. So I need to use parentheses here. 5 times the sum of a number and 3 is the same as means it's set equal to, so this is set equal to 3 times the difference of twice the number and 1. Okay, so we've got the same thing here, 3 times the difference means we're subtracting. Now we're not just subtracting the number and 1, but we're subtracting twice the number. So that means 2 times the number, meaning the same number, n, and 1. So I'm finding the difference. I'm subtracting 2n and 1. So 5 times the quantity n plus 3 is equal to 3 times the difference of twice the number and 1. All right, here's our equation. So I can see that I have my variable in 2 places, and in both cases they're inside parentheses, so we want to use the distributive property. If I have 5 of these, it means I have 5 times n and 5 times 3, and if I have 3 of these, it means I have 3 times 2n and 3 times negative 1. So I'm going to go ahead and multiply that out. 5 times n is 5n. 5 times 3 is a positive 15. That's equal to 3 times 2n is 6n, and 3 times negative 1 is negative 3. Now I still have my n's on both sides, so I want to get those together first. I could go either way. I could subtract 5n from both sides, or I could subtract 6n, but in trying to keep things positive, I'm going to move the 5n. 5n minus 5n on this side cancels to give me 0, leaving me with just 15 equals, but if I subtract 5n there, I'm going to also subtract 5n here. 6n minus 5n is 1n, or just n, and then minus 3. Now my n's are all together. I need to get it by itself, so I'm going to add 3. And negative 3 plus 3 cancels, so I'm left with n equals 18. So that's the value of our number. You're going to try number 2, which says 2/3 of a number reduced by 11 is equal to 4 more than the number. Find the number. All right, in this one we have 2/3 of a number reduced by 11. What that means is we're multiplying a number by 2/3 of our number, reducing it by 11. So we're taking away 11. And that's equal to 4 more, so we're going to do 4 plus than the number. So 4 more than the number is 4 plus n. And we're going to find the number. So this one will look like 2/3 n minus 11 equals 4 plus n. There's nothing to distribute here, but I do need to get my ends on the same side. Remember, this is like a 1n. So we're dealing a little bit with subtraction here. 2/3 is less than 1, so I'm going to go ahead and move the 2/3. 2/3 n minus 2/3 n is 0, leaving me with a negative 11 equals 4. Okay, now I'm going to do this 1 minus 2/3. You can use your calculator, but we could also get a quick common denominator. 1 is the same as 3 over 3, and I'm subtracting 2 over 3. 3 minus 2 is 1 over 3. So I have 4 plus 1/3 n. Now that my ends are in the same spot, I want to get them by themselves, so I'm going to subtract 4 from both sides. This equals 0, sorry. Negative 11 minus 4 is negative 15, which is equal to 1/3 n. In order to get rid of a fraction times our variable n, we're going to multiply by the reciprocal, which is the flip-flop. So in this case, 1 over 3, we're going to multiply by 3 over 1. So we can cancel, 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 leaving me with n equals, I'm going to multiply by 3 over 1, which is the same thing as just 3. All right, 3 times negative 15 is a negative 45. All right, number 3, we have 4k minus 3 equals 2k plus 5. There's nothing to distribute here, but I do have k's on both sides, so first thing I'm going to do is get those together. I'm going to try and keep things positive, so instead of moving the 4 and doing 2 minus 4, I'm going to move the 2 and do 4 minus 2. So you can kind of think ahead in these and make it easier on yourself. So on the right, 2k minus 2k cancels as I wanted it to, leaving me with just 5. And on the left, 4k minus 2k is 2k minus 3. Now that my k's are together, I'm going to get them by themselves, so I'm going to move this 3. Negative 3 plus 3 is 0, leaving me with my 2k as I wanted. And then 5 plus 3 is 8. To get the k totally by itself, I undo 2 times k by dividing by 2 on both sides. 2 divided by 2 is 1k, and 8 divided by 2 is 4. You're going to try number 4. 2m plus 12 equals 3m minus 31. In order to solve this one, we see that we have an m, on the left, 2m, and 3m on the right. We want to first get those together. You can move them either way, but I want to keep it positive, so I'm going to subtract 2m from both sides. On the left, 2m minus 2m is 0, leaving me with 12 equals 3m minus 2m is 1m, or just plain m, minus 31. Now I want to get the m all by itself. I'm going to add 31 to both sides. On the right-hand side, it cancels just like I wanted. I'm left with m equals 12 plus 31 is 43. Looking at number 5, I have 2/5 y minus 8 equals 9 minus 3/5 y. So I also have y's on both sides, and this is like a negative 3/5 y. I want to keep that in mind. So just as usual, even though there's fractions, I want to get these on the same side. So in order to keep things positive, if I subtract 2/5 and I have negative 3/5 minus 2/5, I'm going to get a more negative number. But if I move the 3/5, I can add it. So I'm going to add 3/5 to both sides. So negative 3/5 plus 3/5 is 0, leaving me with a 9 equals 2/5 plus 3/5. The good thing is these already have a common denominator, so I'm just going to add these numerators. 2 plus 3 is 5. 5/5 equals 1. It's just a little side note. So this is just equal to 1y, or plain y, minus 8. So that was nice. Now to get this alone, I'm going to add 8 to both sides. Negative 8 plus 8 is 0, so I'm left with y equals 17. You're going to try number 6. 3/4 k minus 5 equals 1/4 k minus 1. We notice here that we have k's on both sides. Again, there's fractions, but they do have the same denominator, so it won't be too bad. just like we did in the other one. I want to get these together first. They are both positive, so I'm going to have to subtract. So I want to think, do I want to do 3/4 minus 1/4 or 1/4 minus 3/4? I think I want to keep things positive, so I'm going to move the 1/4. On the right, 1/4 minus 1/4, this gives me 0, and I need to drop down this -1. The negative is with the 1. 3/4 minus 1/4, we have a common denominator, so I'm just subtracting the tops. 3 minus 1 is 2, and 2 over 4 is the same as 1/2. So I'm just going to go ahead and simplify that now. I've got 1/2 k minus 5. I'm going to try and get this 1/2 k by itself. I'm going to add 5 to both sides. -5 plus 5 is 0, so I'm left with 1/2 k equals -1 plus 5 is 4. And then I have a 1/2 k, a fraction times my variable, so I'm going to undo this by multiplying by the reciprocal, 2 over 1. So that I cancel and cancel, leaving me with k. And then I can multiply by 2 over 1, which is the same thing as 2. 4 times 2 is 8. Looking at number 7, I have 8q plus 12 equals 4 times the quantity 3 plus 2q. I've got q's on both sides, 8q, and then a 2q inside parentheses. So on this one, I am going to need to distribute first, only on the right-hand side, because I have 4 of these, meaning I have 4 times 3 and 4 times 2q. So on the left, I have 8q plus 12. I'm not going to do anything yet. And then 4 times 3 is 12. 4 times 2q is a positive 8q. Got 8q on both sides, so I'm going to subtract 8q, and watch what happens here. This is unique. 8q minus 8q cancels like I wanted, but on this side, 8q minus 8q is also 0. So you might be like, did I do something wrong? No. What are we left with? I'm left with 12 equals 12. And you ask yourself, is this a true statement? The answer is yes, this is true. So if you end up with something like this, where your variables cancel, but it's true, what that actually means is that we have infinite solutions. It means you could plug in anything you want for q, and it will work. You can try it out if you want to, but that's what that means. Looking at number 8, you're going to try this one. We have 2 times the quantity, 7 plus 3t equals -t. In order to solve this one, we want to first find our variables. We've got a 3t on the left and a -t on the right, but the 3t is inside parentheses, so we're going to first distribute. We have 2 of these, so I'm going to pass out the 2 to both terms on the inside. 2 times 7 is 14. 2 times 3t is a positive 6t, which is equal to -t. I still have t here and t here. Now, normally I would want to try and keep things positive, but in this case, if I keep things positive, I'm going to add t, and I'm going to end up with nothing on this side, which is fine. But in this case, I'm just going to go ahead and move the 6t so that I keep something on both sides, if that makes sense. So I'm going to subtract 6t from both sides. 6t minus 6t is 0, leaving me with 14, equals, this is a -1t minus 6t is -7t. To get the t completely alone, I'm going to divide both sides by a -7. -7 divided by -7 is 1, leaving me with t equals 14 divided by -7 is -2. Number 9, we have 6 times the quantity, -3v plus 1 equals 5 times the quantity, -2v minus 2. I'm going to need to distribute on both sides here. On the left, I have 6 times this, so I'm going to pass it out. And on the right, I have 5 times all of this, so I'm going to pass the 5 out. 6 times -3v is a -18v. 6 times 1 is a positive 6. 5 times -2v is -10v. And 5 times -2 is -10. I have -18v on the left and -10v on the right. I want to get those together. So I'm going to add 18v to both sides. Once again, trying to keep it positive. So negative 18 plus 18 cancels, leaving me with 6 equals negative 10v plus 18 will give me a positive 8v minus 10. I want to get this 8v by itself, so I'm going to add 10 to both sides. Negative 10 plus 10 is 0. 6 plus 10 is 16. Divide both sides by 8. 8 over 8 is 1v, so I get v equals 2. You're going to try number 10. Negative 7 times the quantity 2b minus 4 equals 5 times the quantity negative 2b plus 6. To solve this one, we're also going to distribute 7 times this, so I'm going to pass out the negative 7, and on the right I have 5 times this, so I'm going to pass out the 5. Negative 7 times 2b is negative 14b. Negative 7 times a negative 4 is a positive 28. 5 times negative 2b is negative 10b. And 5 times 6 is a positive 30. I want to get these b's together. I want to try and keep it positive, so I'm going to move the 14b. On this side, get 0. So 28 equals negative 10b plus 14b is 4b plus 30. And now I'm going to get the 4b by itself. On the right, the 30's cancel. 30 minus 30 is 0, leaving me with 4b. 28 minus 30 is a negative 2. I'm going to divide both sides by 4, leaving me with b. So b equals negative 2 divided by 4. That can be simplified, although it can't be divided completely, to negative 1/2. Number 11, I have 5 times the quantity p plus 3 and then plus 9 by itself equals 3 times the quantity p minus 2 plus 6 by itself. So I am going to distribute here. I have 5 of these, so I'm going to pass out the 5, plus 9. This 9 is all by itself, so it's not going to be distributed. Remember, if I'm ordering 3 hamburger meals plus an ice cream, the ice cream is all by itself, so that's the idea here. On the right, I have 3 of these, so I'm going to pass out the 3, but then I also have a plus 6 by itself. So 5 times p is 5p, and then 5 times 3 is a positive 15. And then I drop down this plus 9 equals 3 times p is 3p, 3 times negative 2, 3p, 3 times negative 2 is negative 6, plus 6. I see that I have 5p over here and 3p over here, but I can also simplify these terms. So I'm going to kind of do that at the same time. To keep things positive, I'm going to move the 3p to the left. On the right, 3p minus 3p is 0. And what am I left with? Negative 6 plus 6 is actually 0. Now, that doesn't mean we're just done. It means I write 0. 0 equals, on this side, I have 5p minus 3p, which is 2p. And then 15 plus 9 is 24. To get the 2p by itself, I'm going to subtract 24 from both sides. 24 minus 24 is 0, so I have 2p equals 0 minus 24 is negative 24. And then I'm going to divide both sides by 2. 2 over 2 is 1p equals negative 24 divided by 12. Sorry, negative 24 divided by 2 is negative 12. Finally, you're going to try number 12. Negative 4 plus 5 times the quantity f plus 2 equals 2 times the quantity 3 minus f plus 7. So we notice that we're going to need to distribute. I'm going to distribute the 5 here. I have 5 of these, so I'm going to pass out the 5. But this negative 4 is by itself. On the right, I have 2 of these, so I'm going to pass out the 2. But the 7 is by itself. So let's go ahead and do this. This negative 4 drops down. Plus 5 times f is 5f. 5 times 2 is a positive 10. On the right, I have 2 times 3, which is 6. 2 times negative t is negative 2t. Drop down the plus 7. And I notice, oh, sorry, I wrote a t, but that's actually an f. I was like, that's weird. 2f. Okay. So I've got 5f on this side, negative 2f. In order to keep things positive, I'm going to move this one over. And then I'm going to try and simplify at the same time. So on the right, negative 2f plus 2f is 0. But then I have 6 plus 7. So I'm going to add those together, and I get 13. 5f plus 2f is 7f. And then negative 4 plus 10 is a positive 6. So now I have 7f plus 6 equals 13. I'm going to subtract 6 from both sides. 6 minus 6 is 0, so I have 7f equals 13 minus 6, which is 7. Divide both sides by 7. 7 over 7 is 1, leaving me with f equals 7 over 7 is 1.